Okay. So section 6.2 is going to be about finding the regions between our curves. So what we're going to do is we're going to use the premise that we learned in section 5.2 with our Riemann sums, and we're going to apply that to this section. So what we're in essence going to do is we're going to have two different functions, and we are going to first find our bounds, and we're going to do that by finding where the two functions intersect, and then we are going to integrate and subtract the result, okay? So one of the things that I want you to keep in mind is that this first function is always going to be the function that looks like it's at the top on your graph, and I'm going to show you what I mean by that in a second. So let's go ahead and do this first example. Okay, so what we're going to do first is we are going to plug in these two functions to Desmos. So I'm going to switch the screen that I'm sharing. Okay, here we go. All right, so hopefully you guys can see that. All right, so I'm going to go ahead and graph these. So we have 4 divided by the square root of x plus 1 and x minus 1. Okay, so what I want you to see here is we are trying to find the area of the region of the graph bounded by f of x, g of x, and the y-axis. So in essence, we're trying to find this area right here, okay? And so we can mathematically solve for the intersection, but I think it's just going to be easier if we just use the calculator to help us. It'll take less time. So the intersection point is 3, 2, okay? So, okay, so I'm just going to do a little sketch so that I have that to refer back to, so I don't have to keep flipping to the camera. So we had something that looked like this, and this, and this point right here was 3, 2. Okay, and we were trying to find this area. All right. Okay. So now that we have that, what I want to draw your attention to, this is what I was talking about before. So this function is this upper one right here. So when I'm plugging this into the formula, it happens to line up that it's f of x and g of x, but that's going to be the first one. It's not always going to be like that. So that's why I wanted to draw your attention to it. Okay. So what we're going to do now is we are going to integrate on the bounds from 0 to 3. Now you might be asking yourself, why 0? Well, it's 0 because it's bounded by the y-axis, so my x can't go lower than the y-axis, so it can't go lower than 0. All right. And so what we're going to do is we're going to write f of x down, we're going to subtract g of x from it, and we're going to perform that integration. Okay. So let's go ahead and write this down. So we have 4 over the square root of x plus 1 minus x minus 1. We are integrating that. Okay. So we have a little bit of the u substitution going on here with this first term. So in essence, I have 4 times x plus 1 to the negative 1/2, right? So then I would add 1, which would give me a positive 1/2. And then I would need to multiply this guy by 2. So we'd end up with 8x plus 1 to the 1/2. All right. Okay. So all right, so here we had an x, we add a 1 to the exponent of 1, which is giving me a squared. Since I have nothing in front, I want to put that 1/2 negative because of this sign. And then here with this 1, it's a negative times a negative, which is going to give me a positive 1. And if I integrate 1, I'm going to get x. So now we're going to substitute in 3 and 0. So we're going to do 8 3 plus 1 minus 1/2. 3 squared plus 3 minus 8 plus 1. Okay. All right, and then if I plug all of that into my calculator, I'm going to end up with 13/2. So the area of this region here is 13/2. Okay. Now this next one is going to be a little bit different. And this one's going to be a little bit different because I have this absolute value. So let me go ahead and graph this so we can see this. Okay. So we have x plus 3 and the absolute value of 2x. Oop. Okay. So what you should be noticing is we have two different equations here that happen. One happens when x is less than 0, and the other happens when x is greater than 0. So we're going to have to take that into account. Okay. Okay, so oh, it gets so blurry. Okay, let me see. Okay. So we have something that looks like this, and it matters if x is greater than or less than 0. I'm gonna make that a little bit longer. Okay. So we're trying to find this area here, right? So when x is greater than or equal to 0, we are going to have positive 2x. And when x is less than 0, we're going to have negative 2x. So negative 2x here and positive 2x here. Okay. All right. So let's go ahead and see where the intersections happen. I probably should have done this before I switched my screen from Desmos, but essentially I'm going to get x is -1 and x is +3. And let's do this one mathematically, okay? So this is a little throwback to pre-calc. So x plus 3 equals +2x, and x plus 3 equals -2x. Okay, so in essence, what I'm going to get is -x plus 3 equals 0 minus 3. Could have done that a little bit faster. So x is 3. So that is this here. This is 3, 6. Okay. And let's do this guy. Let me do this real quick. Okay, so that's this guy right here. So that's -1, 2. Okay. All right. So now let's go ahead and set up the problem. So what I need to draw your attention to is if we're doing this part, we're going from -1 to 0, okay? So we're gonna have to do the problem where we're going from -1 to 0. And on this side, I'm dealing with -2x. So that's gonna be x plus 3 minus -2x. Okay, now we have to deal with this section. Okay, so for this section, we're going from 0 to 3. And we're still going to have x plus 3, but this time we're going to have the positive 2x, so minus positive 2x. Okay? Okay, so we can simplify before we integrate, just to make our life a little bit easier. So x minus -2x is going to give me 3x. X minus 2x is going to give me -x. Okay, so now we just need to integrate. So 3 over 2 x squared plus 3x. We're going to evaluate this one on the interval of 0 and -1, and -x squared over 2 plus 3x. And this one's going to be evaluated on the integral of 3 and 0. Okay, so I'm kind of running out a little bit of room, but let me just walk you through what we're going to do. We're going to plug in 0, and then we're going to plug in -1, and we're going to subtract those two values. And then here we're going to plug in 3, and we're going to plug in 0, and we're going to subtract those two values, and then we're going to add the two together. Okay, so if you do that correctly, you will get 6. So go ahead and pause right now so that you can try that. Okay. All right, so the next thing that we're going to go through is the same thing, except this time we're going to be dealing with respect to y. Okay, so this time y is going to be our independent variable. Okay, so that means we're going to integrate with respect to y. Okay, so we're going to set this one up exactly like we did the last one. Okay, so first we are going to plug in the original equations to Desmos to find our intersection point. So let me go ahead and do that now. Okay, so y, oops, okay, we'll do x cubed and x plus 6. Oops. 6. Okay. All right, so here we go. So our intersection point is here, and that is at 2, 8. So this time, since we are integrating with respect to y, we're going to care about the y coordinate of this, which is 8, okay? All right, so let me switch back to, okay, here we go. There we go. Okay. It really does amaze me how blurry this gets when I switch screens. Okay. So now that we have that, what we're going to do is we are going to rewrite our two equations so that they are in terms of x equals instead of y equals, okay? So y equals x cubed is really the same as me saying x equals y to the 1/3. So essentially I'm taking the cube root to get rid of this, okay? If I have y equals x plus 6, that is really the same thing as x equals y minus 6, okay? All right, so now what we're gonna do is we are going to integrate this with respect to y, all right? So we care about 8, so we're gonna do this between 0 and 8. Y 0, because they gave me the x-axis as one of my bounds so that I know y cannot go below the x-axis, okay? So y can't go below 0. All right, so then we're gonna say y to the 1/3 minus y minus 6 dy. And so we're going to integrate now. So we're going to get 3/4 y to the 1/4 minus 1/2 y squared plus 6y. Got two negatives here. And we're going to evaluate that on 8 and 0. Okay, so I'm going to say 3/4 8 to the 4/3 minus 1/2 8 squared plus 6 times 8 minus 0. And if I plug all that in, I'm going to get 28. Yay. All right. Boop. Okay, so let's see if you can do the next one. Okay, so go ahead and take a pause and try this one. It's just like what we were working on before. Okay, so hopefully you tried this one. So I got that x equals y to the 3/2. And then I also got that x equals y plus 4 when I solved these two equations. The intersection point that I found when I plugged in the original two Desmos was 8 and 4. Okay, and then, so this one, in this case, y plus 4 was the upper function. So I did y plus 4 minus y to the 3/2 dy. All right, so then I integrated that, and that gave me 1/2 y squared plus 4y minus 2/5 y to the 5/2. And then I'm going to evaluate that at 4 and 0. So I'm going to plug in 1/2 4 squared plus 4 times 4 minus 2/5 times 4 to the 5/2 minus 0. And I got 56/5. Okay, so remember, you always want to check to make sure which function is the upper bound of the function. Okay. All right, we got two more. This one's kind of cool. All right, so in this case, what I did was I set them equal to each other. Okay. And so then what I did was I cubed each side. So then I had x squared equals 64. And then I took the square root, and that gave me x is equal to plus or minus 8. Okay, so what this tells me is that my integration is going to happen from -8 to +8. Okay. All right, and then I plugged into Desmos to see which one of these was the higher function, and in this case, it's the 4. So we are going to integrate 4 minus x to the 2/3 dx, which gives me 4x minus 3/5 x to the 5/3. Evaluate that on the interval of 8 and -8. And if you substitute in 8 and then substitute in -8 and subtract the first minus the second, you should get 128/5. Okay. All right. Last one. Okay, so for this one, I again went ahead and substituted in the fact that y equals x/4 into here. Okay, so what did that give me? x/4 to the 3rd is equal to x. So then I went ahead and brought in the cube. So I got x cubed over 64 equals x. Put this over 1 and we can cross multiply. A little blurry. Let me see if I can. That's better. right? So then we get x cubed equals 64x. Okay. And then if I subtract that over to be with my x cubed, I can then factor out. So I'm going to get x equals 0 and x equals plus or minus 8. Why plus or minus 8? Because x squared minus 64 equals 0. So x squared equals 64. So then x equals plus or minus 8. Okay, so now something kind of cool is happening with this one. So let's look at this one on the screen. All right, so we have y equals x over 4. Ooh. 4 and x equals y cubed. Okay. So something really kind of cool is happening here, right? Look at this. So it's kind of like a mirror image of each other, right? So what I want you to think back to is your symmetry, okay? So in essence, go back to, here we go. So we're going to write down our original. I'm going to switch this to say that y equals x to the 1/3, just because I want everything in terms of x's so that I can integrate in terms of x's. So in essence, what we have going on is from -8 to 0, x to the 4th is on top and x to the 1/3 is in the bottom portion of the function, right? And we're going to add that with this, and essentially they just flop spots, okay? All right, and so let me just make sure that you guys know what I'm doing. I want to draw a little picture here. So we had, let's see, I'm gonna try to make this as pretty as I can. Make this straight line first. Okay, so I'm not so amazing at drawing, but you're just gonna deal with it. Okay, so in essence, we have this point here, which is the 8, 2. This is 0, 0. And this is our -8, 2. Okay, so the x over 4 function is on the top here, okay, and the x to the 1/3 is at the bottom, and then here the x to the 1/3 is at the top and the x over 4 is at the bottom. Okay, so that's why they essentially switch spots for these two pieces. Now, we were just talking about how they're pretty much symmetrical, right? So what I could do is I could only evaluate one of them, and I'm going to pick this one, but I could put a 2 in front to take into account that there were two pieces to start with. Okay. It's all about doing less work, right? X over 4 dx. All right, so then now we can just integrate this. So we're going to get 3/4 x to the 4/3 minus x squared over 8. And we're going to evaluate that from 8 to 0. Take that into account first. So we're going to end up with 12 minus 8. Plugging in 8, plugging in 0. And we're going to end up with a final answer of 8.